Hi everyone, this is the ESP Revision Lecture for U22059 Enterprise Systems and Processes. And what I'm going to do, as you can see on the screen, I've got the revision lecture up, but I haven't got it, I'm not playing it as a presentation, so I haven't clicked this bit here. I'm just running it so I can go backwards and forwards through it if I want to. So let's just have a look at the first of the items on the screen, IT alignment and flexibility. So before you can do anything with enterprise systems, you need to make sure that your basic IT, the underlying systems, the underlying hardware and software is actually in a good state to start with. And one way of modelling how good a state it's in is to look at whether you've been through this 4 phases of flexibility to simplify your information technology. So there are 4 phases. You have the isolated phase, the standardization phase, the consolidation phase, and the modularisation phase. And they are defined in this document which I provided on Moodle. So let's just have a look at that. This is the reason why I'm not running the presentation. I can just slide it out of the way. So on this page, on the Moodle site, we when we defined effectiveness and alignment, we looked at a lot of different things there. And you'll find that simplification of IT document is available there. So if you were to click on that, which I've just done, and hopefully there we go. You'll be able to bring up this document, and this goes through the 4 phases of IT flexibility. So if you were an IT manager, this is what you would do as a director. You would go through the different phases. So the first phase, you have undefined assets. Quite often, if you've had companies that have been taken over, then they'll have different types of IT systems running in the acquired companies than in the parent company. So you look at define. The first thing you want to do is see what those assets are. But in the first instance, the isolated phase, they're undefined. You may have lots of servers doing various things. You won't know what they're doing. They could be drawing a lot of power, but not being loaded very heavily. You have IT silos. Data can be duplicated in a number of places. People hold on to their information. You have incompatibility of systems that won't talk to each other and may require you to have electronic data interchange, which is kind of a mapping of inputs and outputs. You still do mappings in process orchestration, but it's that's a much more well-defined process than we're talking about here. And then you have a lack of process, so there's no kind of identified way of improving things, of resolving system incompatibilities. So that takes you to the standardization phases, where you take some action. You bring in asset management to work out and to manage which assets are kept and which are retired. You look at interoperability of systems. Working to common standards, so the devices all work to the same standards, and therefore they are likely to interoperate better. You start to have process definitions, and the IT infrastructure library is a framework by which the Office of Government Commerce, for example, defines how you might do that. That's in the UK. And then you have vendor rationalization, so you're effectively cutting down the number of people you buy things from, and with the idea of making the systems more reliable. So that's the standardization phase. What you don't want to have are a whole load of remaining IT silos, because if you do that, if you've got IT silos, then if you're heading towards an ERP route, ERP and IT silos are complete opposites. You don't want that. You want one set of data held centrally and then rebroadcast in one format or a number of different device formats to the rest of the company. Then you have consolidation phase. So this is where you centralize your data, you consolidate your assets. Through asset management, you retire some if they're being less well used. Data integration, you can make that happen through the use of web services, for example. You define a common platform, so you might only use one brand of database instead of having multiples. It could be Oracle, it could be IBM DB2 or Microsoft SQL Server, or it could be SAP, one of the SAP databases, HANA being the obvious one. And then you go about process improvement, so you have process re-engineering, and you will probably have thought about what the processes should be like through analysing that. Either you can buy in a bespoke solution or a commercially off-the-shelf solution that will give you process improvements. You could also work with consultants to, and we've done that to death really in the courseworks. So in you have network convergence, the use of as few as possible network technologies, right sizing to make sure you don't have over the top bits of hardware that you don't need. And so one of the ways of doing that is to virtualize your hardware so that you divide it up into logical sections that can be defined in a virtual hard disk file, which can be set up on demand. So you can run a virtual hard disk file, or you can submit it over the internet and run it up somewhere else. And so that's really the kind of like grounding of how the internet now works in this kind of on-demand I've forgotten the name of it now. Instantiation of objects. So it might be a server object or a workgroup object that you want to run up. So asset virtualization is kind of key to the way the cloud works. You have IT as a service enablement. So by defining all your processes as web services, which is how SAP NetWeaver works. That's in the case of an SAP platform, it's all based on NetWeaver, and that's web services. You might have a modular platform, so you use a modular platform that can be rolled out in. So you might have specific server racks or infrastructure or routers, etc., that you use regularly. Process componentization is so here you are providing a route to modernization of standardized systems. The components, so it could be a database or event controller that you have turned into basically a component that you can take in and out easily to make your systems more flexible. And then grid computing. Grid computing is really a way of setting up computing assets on nodes, and there's a certain amount of overhead in maintaining a grid, but it's all part of cloud computing now, really. And then you have ERP and service-oriented architecture. That would be the next thing. IT governance, bringing that in to make sure that you actually run all your IT assets properly, and you don't allow server sprawl and those kind of things. And then you align your IT with business goals. Once you've done all that existing consolidation, turning things into virtual computers, making on-demand access to IT resources possible, then you can start to think about, what do I need to do with this IT? How can it help the business goals? And it's at that point that you do it. If you do it too soon, then you can lead yourself into the IT alignment trap, which we looked at. So I'll just come on to that in a second. Unified communications, obviously showing people's presence and preference on the network. Presences, are they available to do work across time zones, which obviously makes it easy to communicate with them at a particular time globally. And preference, what's their preferred method at that moment of communication? So they might be on the road, in which case they'll be on a mobile, or they might be in the office, or they might redirect to their office. That's preference. So unified communications allows that. So coming back to the, if I can just drag it over again. There we go. So we talked about the alignment trap, and so let's just look at this. We looked at an analysis of a trader, Charles Schwab, and they used IT to provide quotes for share trading to analysts, etc. So if you try to align your assets when you haven't consolidated them and made them modern or modernized them, then you can put yourself in the alignment trap where 13% of your IT spending, you're basically spending a lot on IT, but you're not achieving sales growth as a result of that extra spending that you're making on IT. Where you would like to go first, if you're in that situation, is to go to the maintenance zone, where you cut down your IT spending and you consolidate and try to get yourself into a position where you've got good, well-oiled IT, which is the next step. And here you have a much lower than the average company spend on IT, but you're starting to get some sales growth out of it. And then finally, where you want to get to is IT-enabled growth, where you're still below the cost of the average company in the market, but you're getting lots of growth, sales growth and sales leads, and possibilities out of your IT system. It's really delivering for you. It's enabling the company to go forward. That's where you want to go. So if you're in the alignment trap, we need to move around in this kind of direction to get yourself out of that. So that's IT alignment and flexibility. So please do have a read through this and read through this. It's something that there's quite a bit we covered on that, so it's something is going to come up, and it might be you won't typically be asked to remember these figures. This exam is more about, can you make a choice from a series of options and make a sensible choice. So let's have a look at the next one. So system implementation. So the first thing I've looked at in there are change agents. So what are change agents? Well, particularly when you've got an ERP project, which is a very complex project that involves human issues, bringing teams along with you, in those situations you need not only the people who are installing the hardware and software, and you'll have a project board which will be making decisions on what hardware and software to buy and when to buy it and how much it's going to cost and what's acceptable. They'll hopefully be doing things like benchmarking other providers, and we went through a whole gamut of things that you need to do, which you'll have covered in courseworks. But change agents are important because they typically are well-respected people within a company who work with the company. They could be consultants as well. That's the other thing they could be, who work with the company to influence teams to identify bottlenecks and problems and things that need to be removed to progress. And so these are kind of skilled project managers, but they also have a human side to them. And we saw in, for example, the Nestle case study that it's very important that you have a change agent on board, and don't just treat one of these IT projects as either IT installation, even an IT implementation. You also have the human side. You've got to bring people along with you, and take on board their very real concerns about what you might be doing to the system that they know and love. So change agents is an important issue. ERP or SOA or both. So one of the things that we covered in one of the early lectures was looking at what you can do with systems, and to go to a web services architecture. You use this to form your ERP software, and most ERP software now is web-based. Even if it may be delivered on premise, it's still running as web services. So in this particular case study here, it looks like they decided to standardize IT infrastructure on IBM and then adopted SOA at the end there. So this is a kind of process: formulate the business strategy, make IT infrastructure investments, align the IT infrastructure with business goals and processes, replace legacy systems and outdated technologies, and maybe you would have done that first, I would have thought. Then standardise the IT infrastructure and adopt SOA. So this is a kind of business process, and you should probably have an understanding of that after this course. Another thing we looked at was when we're actually designing, when we're putting in a new system, we have to decide before we purchase a system what we're going to do with our business processes. Now, if you're buying an ERP system from someone like SAP, they will have defined what is best practice in the software and the modules that you're going to buy. And so in that case, you'll be changing the way your business processes work to the way the software works to a certain extent, which seems the wrong way around. But actually, why would you go and buy a very expensive bit of software that has best practice in it and then try and change it to the way that you work already? What you'll end up with is an expensive bad process or series of processes. But you might choose instead of that to design a system from scratch, or to couple various modules together, and so you might have a need to map processes. And so here's a typical process map in kind of schematic form. So you have a couple of three departments there: sales, accounting, and manufacturing and production. And in the first section there, in sales, an order is generated, and then that order is submitted out of sales. And accounting then do a credit check. They'll approve the credit and generate an invoice. That's their other bit of involvement later on. Before they do that, after the approval of credit, then the product is put through the shop floor, and then finally it'll be shipped at the end, and accounting then get back involved and generate an invoice sent to the customer. Notice there are a number of things about the process mapping. You've got some horizontal lines there which divide the different actors. There's actors in sales, accounting, and manufacturing and production. And then you have the processes themselves which kind of move about across these swim lanes. It's almost like a swimming pool where people in different lanes do have different activities. But the process is cross-company and works its way across these different swim lanes. So that's process mapping is something that will be involved, and you'll have come across it in all kinds of IT programming, high-level looks at programming. There are a number of SAP ERP modules. So here we're looking at SAP Business Suite. So what is that? What's core and what are add-ons? In the lab we've been looking at SAP ERP, and there have been lots of modules. So you've got materials management MM and sales and distribution SD. In what you're looking at here in Business Suite is that you have ERP, you have supply chain management SCM, product lifecycle management PLM, supplier relationship management which deals with purchase orders and that kind of the purchasing side. Supply chain management is obviously inventory and manufacturing and making the product. Product lifecycle management allows you to manage the drawings and assets and that you need to make things and to design things. And then you have customer relationship management, CRM. And this deals with this. This has a higher level look at sales ordering and internet sales, but with a view to increasing business through treating customers better and having a better relationship with them. So you have SAP at the core, and then in Business Suite you have those four other modules, which are all part and all run, and SAP NetWeaver web services run underneath the ERP platform, helping it to run efficiently. So here we have the thing that we've used in the lab, which is ECC, that's ERP Central Component, and this shows a client server look at it, but nowadays this is all based on web services. And so you have sales and distribution, materials management, production planning. We looked at those modules. We looked at financial accounting, CO, which is controlling or management accounting. Then you've got asset management, fixed asset management. You've got a project system. You've got a workflow management. We haven't used those. We did have a quick look at human resources. We didn't look at plant management, but that's an important module, and quality management. So those are all modules that are part of the ECC, ERP Central Component. In other words, SAP ERP. This is this is the core of SAP Business Suite. But then, if we go back to this previous diagram, on top of that, in Business Suite, you have these other modules. Okay. On this slide also we have middleware. So what's middleware? Well, it's a very important thing in that it connects up, it integrates applications. So here we've got applications doing things in the warehouse, in transaction management, linking to freight and distribution. Over here we've got the manufacturing planning system, and these are all applications that have to be linked together, and that's what middleware does. That's pretty much what it does. It's quite an important thing, and every bit of software of an enterprise nature will have some kind of middleware. So thinking about the middleware for a second, we looked at process orchestration, and you're not going to be expected to remember a lot of that in the exam, but you do need to know what process orchestration is and how it relates to middleware. You can think of different type of mapping there, so just have those things in your mind in the exam. Again, the exam format is multiple choice, so you're only going to be asked to make a selection from a series of options. You're not going to be asked to write an essay or to even write one word. It's all multiple choice, or and I'll show you the format right at the end of this little presentation. So process management. What are composite applications? Well, down at the bottom of this diagram down here, there are various services. So you've got CRM, you've got Business Warehouse, you've got ERP, and you've got the databases that are down here running these things. Through service enablement, you can make connections out of this area through middleware in the applications integration section, using web services. And here we have a business logic layer. So here, business objects, here's the intelligent part of Business Intelligence, and here Business Warehouse is a kind of snapshot taken of live transactions, which are put in here to enable you to do analysis offline kind of thing. But supposing you were one of these people in one of these roles, so you might be a sales manager, and you wanted to extract a composite view, taking some information from the ERP system, some from the CRM system, and you wanted to have that presented to you via a series of devices. It might be a tablet, it might be a computer. You could have somebody, and it would be typically an experienced programmer, one of the more highly paid programmers, who would use the composite application framework, which is this part of SAP NetWeaver. So it's an element of SAP NetWeaver, the platform that all this runs on. You can see that you can integrate .NET and IBM WebSphere with it, and there are other integrations. NetWeaver is a very powerful platform. It handles all these different things like people integration, information integration, process integration, the application platform, which is Java based, and there was also ABAP, which is SAP's programming language. So we covered that probably in one of the lectures, the SAP NetWeaver and what it offers. So you might be asked a few questions about that. You might be asked about what are composite applications, or how does that work. So it's you're using an advanced programmer to make a composite view of data down here at the user interface, using composite application framework tools that are available, which SAP provide. In the case of SAP, other ERP vendors will have something similar. So process management. So here's what's called business process management notation, and it's a way of looking at a business process and seeing what happens in a kind of informal way. And so that method of doing things is also provided in Visual Studio. You've got something like this. IBM have their own systems for drag and drop creation of business process maps using this kind of notation. So business process management notations are a key element of showing how a process goes together, and so that's important to think about that. We looked at in-memory computing. So what is it? Well, SAP HANA is a database. It's an in-memory database, so it puts its data in columns. Why is it important? Well, relational databases are quite slow and they don't like empty fields. They're not designed to have empty fields. In fact, they're designed to have inbuilt checks to make sure that data is cleansed. Empty fields are filled in with sensible answers to make sure that the database is always going to give a correct and full answer. But columnar databases and very fast databases that run 10,000 times faster, because they run all the transactions, all the calculations in memory, which runs much faster than storage devices, and there's no access time or a very low access time. You can actually run SAP Business Suite on the SAP platform, and the most recent incarnation of that is SAP have just launched an ERP version called SAP S4 for HANA, and that is a very close integration of Business Suite with SAP HANA, and a lot of companies are moving over to it already. So that's been a gamble for SAP, but it's certainly going to pay off, I think. You have SAP NetWeaver Business Warehouse alongside Business Suite. Here's the user interface, and there are various different ways of interacting with the system, like mobile or via websites running on HTML5, or through business objects, business intelligence tools, data visualization, that kind of thing. So in-memory computing is fast, something like 10,000 times faster than an existing system, and it can handle large volumes of data coming in at a high rate, and it does that by storing data in columns in an in-memory database. So you can have SAP Business One running on SAP HANA if you want. There are a number of different options. So we looked at SAP NetWeaver. What is it? A platform for SAP ERP, certainly. SAP Business One, all sizes of a company can now base their ERP system on SAP HANA, but also you can now, at one stage, SAP Business One was not, it basically was still client-server. It wasn't a web services based system that used SAP NetWeaver, but that has changed in the last year and a half or so, and now all SAP's products are web services based, they're web enabled, and can run on SAP NetWeaver, which means they can all be nicely integrated through NetWeaver, and different systems within the same company, so Business One, Business Suite, Business ByDesign, can all talk to each other via NetWeaver. Web services, what are they? You'll have probably had Adrian telling you all about this. It's kind of his specialty, really. But in this case, what we're looking at is we have a service provider and we have a service user. And what we're doing over here is we're trying to find out, discover, using this discovery language, what web services are available. And so within a company, you'd have that. You'd have a system where, for example, an ERP system, it would continually be discovering where what web service was available and picking one to run the ERP system. Every business process would have a web service. Every sub-business process would have a collection of web services that would run it. So this is what web services are, and so you want a web service, you go and discover what it's available, you then retrieve that web service and feed it to the user, and that's a kind of simple way of looking at it. The use of web services as business processes and the business process repositories that lots of companies have, because web services are effectively the company and how it works, has led to a number of entities being set up. Now, it could be that your CIO was a cloud services broker or a service broker, because some of these web services are running in the cloud. You could be running your whole ERP system in the cloud if you wanted to. Certainly very possible. What's happening now is that you have enterprise cloud service brokers, and these service brokers are aggregators. Effectively, they allow your company to make use of web services through an aggregated interface. What's called cloud services brokerage. So you can have customization brokerage, so you can use certain services that allow you to customize your software. Integration brokerage, which allows you to integrate services together. And aggregation brokerage, which brings all these things together and distributes. For example, these systems down here might be chosen by people up here, or vice versa. Linked together. So brokerage, aggregation, it's bringing the services into one web interface, and allowing people to make use of useful web services in a commercial manner. Okay. Here's a SAP Solution Map. It could be any, Oracle will have a similar thing. So what a solution map is a list of the different functional areas, so analytics, financials, human capital management, and then against those what the different modules are. So it just is a map to show you what's available, but typically SAP Solution Maps, you would be able to double click on this. This is just a net graphic obviously, but if you were to double click on this, it would decompose that inventory and warehouse management into inventory and warehouse management, and then you could double click again, and eventually you can get down to the smallest web service, and it will show you exactly how the whole system is architected. So SAP Solution Maps are actually a very powerful way of seeing how a system works. It's a kind of high level view. So that's SAP Solution Maps. So you might find that some of these things are actually, financial accounting is part of a number of different SAP Solution Maps. Okay, so now here we've got product lifecycle management. So we have there's the drawing of an engine here, and there are bills of materials which made it up. You've got change records showing what bits of it have been moved in and out, where you've made a change to how it works. And I can't remember what those actually are. If we just blow them up for a sec, if I can, well, I'll leave you to go to blow that up yourself and have a look. But the change record here is the most important part. And notice under product lifecycle management, you've got a number of elements. You've got product management, you've got product development and collaboration, so that involves product quality management, it involves rapid application development. These are kind of like departments within that function, and it's all managed through this bit of software called PLM. You've got product data management. Now some products are physical products like this engine that you can see here, but other products are you might have a process industry, in which case Making a bit of steel might have a recipe to it. There's certain elements that have to be part of that steel, certain temperatures that it has to be alloyed at, or it might be that you have to have a certain recipe for plastic or brass when you're extruding a product, or it might be that you've got a vat full of some chemical that has to be mixed in the right proportions to make another chemical, in which case you'll have something called a specification and recipe management. So specification and recipe management is really what defines how that product is made, what defines it being different from another product. And it can be both discrete like this or process based. Okay, we mentioned business intelligence, and I wouldn't focus too much on this. We will cover this much more at level 6 for those of you who are doing the BI option. So just looking at this quickly, we have SAP NetWeaver Business Warehouse. We have something called the Business Explorer Analyzer, where you can actually go in and start setting up the business or make queries on the Business Warehouse. You've got Business Objects Enterprise, which allows you to use the Business Objects Server. You've got Web Intelligence for querying the web or using the web. You've got Crystal Reports. SAP bought Crystal Reports, and it's now the main way to extract reports from a business intelligence system. And you've got SAP Crystal Dashboard, which used to be called Excelsius, and that is a means of making dashboards that you can link your underlying data that you're finding out here and present it via a nice interface which works well on mobile, etc. And you have predictive analytics down here. There's data visualization. There's lots of things which we'll talk about more in level 6. Here's a kind of schematic of how this works. There is something called extract, transform and load, ETL, and in a business warehouse that's very important, because first you have to extract the data in some form that the system can take in. You transform it into a series, through mapping, into a series of inputs that it can take into the format that the business warehouse works with, and then you load the data. So that's both master data and transaction data. And here you've got this Rubik cube, which is effectively where you can put data onto these faces and rotate them just like a Rubik cube and get results for example, show me what is the sales in Singapore this year and last year compared to sales in the USA, for example. You can do all that kind of comparison using this kind of online analytical processing. So that's online analytical processing. This is an OLAP cube. So I'm not going to spend much more time on that. We looked at information integration. So here we have information integration, which consists of business intelligence. You've got knowledge management, lifecycle management, and master data management. So in each of these sections, you can see there's different elements. So in people integration, you've got multi-channel access. That allows you to access a portal via a whole series of devices, through the internet, through mobile, through a client server system, for example. So there are these 4 main areas, and then you have lifecycle management, which we just covered, and well, a similar thing, and composite application framework, which we covered before. So just thinking about this information integration, one of the things there is MDM, or master data management. So what is that? So master data management is where you are managing, you have master data, which is the setting up of buckets to receive transaction data. So there are certain rules about how you do it, and you have a team that manages that master data, the consolidation of it, distribution of it, etc. And to see it in practice, you really need to be looking at a business warehouse or or the system more practically than we have done this year, bearing in mind the time constraints, etc. So master data management is part of information integration. Multi-channel access of devices is part of people integration. Process integration's got an integration broker. It's also got business process management for designing business processes. That all happens in process integration. And then finally you have the platform it all sits on, which is Java 2 Enterprise Environment, or ABAP based, and that's where you have your databases and abstract your operating system, so you're not reliant on one particular one. Okay, so we then looked at cloud, and in the cloud infrastructure we have various different options. So you can have infrastructure as a service provided by people like Amazon Web Services. They're very good at that. They have just become a $5 billion company, just as Amazon Web Services, which is a big gain, really growing quickly. You might choose to, instead of having them provide, so you might ask them to provide the operating system, virtualization, servers, storage and networking, and then you do the applications and data, the runtime environment like Java, and middleware. You handle the orchestration of different processes. That's where you just get the basic system infrastructure given to you. But you could also have the middleware operating and runtime environment provided by the external provider, in which case all you've got to provide is applications and data. And software as a service, a whole lot is provided. So, and you could also have yourself managing it all, but obviously there's a lost opportunity to outsource some elements at a lower cost with that. So what makes this work? Well, one of the key technologies is this virtualization, because you can't shift systems and software about without having it virtualized, and a system being defined as a software file, a virtual disk file. And the virtual disk file, VDI file, what it does is when the computer starts up, it divides up the physical hardware of the computer into logical sections, and then it says a certain amount of memory, CPU time, network interface time, disk space is allocated to this virtual machine. So the virtual machine's got a part of the physical hardware. It then runs the operating system. On top of that, it's got a series of applications, and alongside that you can have another one. Now these can be run up on demand, so you could have 20 virtual machines running on one server, or one server in a rack, and obviously you could have lots of servers in a rack, so potentially you can have lots and lots of virtual machines. If they fall over, you just reload the virtual hard disk file or VDI file, and it runs up again. It's the basis of cloud computing. Platform as a service, here are some key providers. Windows Azure is a platform as a service. Salesforce.com have got Force.com, which is their cloud platform. Google have Google App Engine. These are all platforms as a service, although typically there is some movement between Amazon in this area moving up here and Google with App Engine moving down here, trying to cover the market. But that's kind of delineation as it is at the moment, pretty much. Here's Amazon Web Services. Look at all the things that they can do. So they offer ERP, they offer software as a service apps. You can have flat files and Excel, they can store that, databases, they handle middleware, they handle the design and management of web services and support applications. Here are so Amazon EC2, it has virtual computing instances, pre-configured templates of instances. So this is like a small IT system server that you can run a VDI file and immediate, or they call it Amazon Machine Image, and you can run that up very quickly. You can also have an Amazon Elastic Block Store. This is a storage device, so you can either have a place to run applications or a place to put storage, and just have a look at Amazon Web Services and just satisfy yourself what all these different options are by going to their Amazon Web Services site is probably the best thing. I think that's enough on that. Here we've got SAP Business ByDesign. This is a software as a service version of ERP run by SAP on their own servers, and it has a means of configuring. So you have a configurator that you define which modules of the ERP system you want. You pay a subscription and it tells you in the configurator how much it's going to cost you per month to run it. One of the advantages of software as a service is that you will have you'll have a you have the right to stop paying the subscription and lose the service straight away. With an ERP system, that's not really an advantage. What is an advantage is being able to expand as you grow as a company. So you can choose to click a box, see the extra amount of subscription per month that you're going to pay, and if you can afford it, then you can have that extra functionality from your ByDesign system. The system is split up to look at front office, which are these elements in green, the delivery area, which are this area in blue, and then you have the back office, which are these beige elements. So in the back office you have finance, procurement and HR. So back office is really a place where they're not handling orders, they're more kind of providing a service. Then you have to the rest of the company. Then you have supply chain orders, supply chain, production, warehouse logistics and project management of some contracts that are dealing with dealing with the delivery of components or products or whatever it happens that the company sells. And then at the front office you have sales, marketing, customer relationship management, services and support, and that's all to do with providing a better service to the customer at the front end. So you have front office, back office, delivery. So if you're in any doubt about any of those, just think, are they in direct contact with the customer? Are they only dealing internally? Do they have anything to do with delivering the product? If not, then it's back office. Okay, so securing the IT as a service enterprise. Well, we know who's accessing what. Scrutinize via record keeping in more detail those with higher access rights. So this is where you're trying to secure your enterprise. Limit access based on user context. So if they're mobile, they're on mobile device, then you give them less rights than if they're in your actual office. Take a risk-based approach to cloud access. So there are some considerations for securing the enterprise that you need to think about there. So just go onto that lecture and have a look. Business process re-engineering. Some of these have failed. Kind of opposite of business process re-engineering is Kaizen, really, where you do continuous improvement. And there have been projects where Kaizen would have been a better fit than business process re-engineering. So that needs to be thought of when you're considering what kind of way you're going to enhance the prospects of your company. So look at business process re-engineering. There was quite a big section on it. You will probably be asked some questions on it. But don't go over the board because there are 60 questions and we covered quite a lot. So that's what I would say. One important element. Rumble Rack are a consultancy, and here's they did an analysis of in companies what they thought was the best way of improving the company, and by far and away process improvement came out as the most important thing. You can see it's something like 35% greater in importance to any of these other areas like outsourcing or making alliances, better managing your sales and channel management, etc. So that's worth thinking about. Tenets of BPR. So we also looked at in BPR what are the key elements of a successful business process re-engineering strategy, and some of those are getting the people who use the output of a process to go upstream and try how to make that process and see if they can recommend things that would improve it and would make their life easier as well when they're receiving what comes out of that process. Organise around outcomes, not tasks. So you want to have the outcome happen, not necessarily what tasks make it. So that shows you can improve the tasks really. Merge the information processing work into the real work. So get the people who are actually doing the work to also be managing the decision making to a certain extent. The administration not have a separate department for that. Treat geographically dispersed resources like centralised ones. Well, with ERP, that's one of the things that you're trying to do, centralise data and centralise the way things work. Link parallel activities instead of integrating their results. So so you put activities in parallel and you link them together in parallel perhaps. Put decisions and control in the hands of those who do the work. So what you don't want is decisions and control in the hands of kind of managers. You want the decisions to be made by the people who are actually doing the work, who know how that process works well and can be made better. There have been lots of instances of people who know how to improve the system but have to continually work it badly because there are other people who think they know better in how to manage it. This has gone on for years and will still be going on in lots of companies. Capture information once and at its source. So you're thinking about inputs, transformation of what's done, outputs and outcomes. Process mapping. Well, we looked at process mapping before. This is just a more grown-up version which Rumler-Brack came up here. We have the swim lanes again. These are the actors in this application development process here. So we're gathering initial requirements, we're building a wireframe model in this case, we're updating the requirements based on what we've learnt, construct a work breakdown structure for the project. Is it a suitable project? Yes. Then allocate the resources, do these various stages. If not, stop. So it's a tried and tested way of planning out a project through working out what processes are going to be done by what actors in a graphical format. You need to decide what to re-engineer. So which processes should be re-engineered first? And one of the first ones is a product or a process that has high volumes of products and low margins. So if you can re-engineer that so that you can make more profit, even slightly more profit, because it's high volume, it will make a big difference. And there are these other, so high defect, high reward activities. So something that's costly, if you have a big defect in it, costs you a lot of money. So if you can obviously re-engineer, that's good. High skill, time intensive activities, maybe re-engineer that to take some of the skill out or to manage it better. So there are some options there for what you might choose to re-engineer. With any project, you're going to have a certain total cost of ownership, TCO. So this diagram here shows you a kind of breakdown of where the costs are happening. So you have some one-time acquisition costs that happen at the beginning of the project. That may be equipment you've got to buy, hardware, software. It could be plant and equipment, production tools. You will have certain process costs that will be the same all the way through the process being run. You'll have some recurring costs which will pretty much be the same, although there will be a different size of cost. You'll have technology costs where they tend to fall off as the project gets nearer and nearer to being ready and finished to go, system being ready to go. But the opposite is true of people costs. They'll be rising all the way through as you bring on more people, as you go from a pilot project through to full implementation. Things that differentiate one ERP system from another. What makes you choose an Oracle one over a SAP one, for example, is cost of the software licenses, the amount of implementation services and their costs, and maintenance costs. Those are the things which can differ significantly between vendors. What doesn't influence the ERP selection are database licenses, because you have to have those anyway. Internal HR costs, they'll be pretty much constant, as opposed to the kind of like bringing on other people to work on the project and to when you go full scale with it. And hardware costs, you're pretty much going to find the hardware is similar between, for example, SAP and Oracle in terms of cost. Choosing a software as a service solution may not achieve as big a saving as was expected. Quite often this is found because you end up having higher HR costs than you were expecting, because you were expecting to outsource some of those people, but in the end you find you're redeploying them to do other things. So you don't necessarily have that big impact in HR, although you can have. Other extra costs. Well, you obviously buy the software, so if you're buying a new system, and ERP is an expensive thing, so you'd think that that would be the only cost, but in actual fact you have what's called something called an implementation ratio, and you'll find that for every £1 of software licensing costs, there's quite a good rule which says £2 is allocated to cover implementation costs. So you might not have thought that at the beginning, but there's quite a large sum of money that is extra on top of buying the software and the hardware, etc. To limit your exposure to this, make sure that consultants, unlike what happened at Fox Mayer, they had no control over their consultants there, you need to ask for a cost ceiling, and you also need to ask for the kind of people who sold you on using them as consultants to actually perform the job that with you, and not have juniors coming in who have no experience and will cause you a problem in your project. So implementation ratio quotes will be higher for complex software, and really the costs of implementation relate to the complexity of the business processes. Whereas the number of users only impacts user training, really. ERP package selection. So there's a process. You do a market survey, you do a request for information, requirement analysis, request for a proposal, you narrow down the choices, do a site survey, do some demo days, get the vendor to demo to you. You might have reference days, you can go and look at other similar packages. You do a fit gap analysis of the choice that you're going to make of your primary choice of vendor and package, and then look at that against the other ones you might have chosen and see if there are any gaps, and you might find that you need to change to a different choice if there's too many gaps in the one you've chosen in what it can do. So you have an implementation methodology, you make a proposal and then decision and negotiations, and then you buy the software and start the whole project off. You won't be asked to remember these things, but you might be asked to put them in the right order, because some of these are similar. You need to know the order and what they're actually doing, so just gin up on that. We want to minimize single point of failure in the hardware side particularly, so we'll have hot pluggable disk drives, RAID arrays, disk arrays, redundant network interface cards. In other words, if one fails you can switch over to the other one straight away without any downtime. Error checking RAM, redundant CPU, so if one fails you've still got the other one. Redundant power supplies and fans, so that if they break down you've still got the other one. You can also put together what's shown here, a series of computers into a cluster, and link them via fiber optic cable, so if one fails you can switch over processing to another one. You could also have redundant network architecture for what was my SAP when I did this. It's now SAP ERP. And so what you notice here, all these links are broken, but we still have one viable path through the system available without to avoid downtime. Okay. Okay, so next one. So we could spend lots of money and have virtually no downtime at all. And this diagram on the right hand side here, it's showing that would cost us $3.8 million. But for 47 minutes less uptime, we'd only be spending $900,000. And look at the difference in uptime we've achieved. We still have pretty much a very good uptime. So it may be that as long as we're prepared to tolerate some risk, if you're a ministry spec or an atomic plant, for example, you probably have to pay this. Anything less than this would be a sensible choice. Here you've got a lower cost, but you've got quite a bit of extra downtime being factored in. So it's down to you to make a choice, but you can see that through this curve, 1 times, 3 times, 12 times, you can see where the sensible point is for your level of risk propensity. Okay, so sales processes. We saw this in the lab. We have the sales activity. You have an inquiry. After the inquiry, you turn that into a quotation, and the system allows you to turn the inquiry into a quotation easily using templates. You then turn the quotation into an order. The order will have involve a delivery, transportation, shipment, and billing documents follow after that. That will feed into accounts receivable in the accounts package or in financial accounting. If you've issued goods, then there will be a material stock account that will change as you. If you've made something, it will increment, and if you sell something and it leaves the factory, then it decremented the stock level. And then you've got, outside of that, you've got materials management, production planning, but this is kind of like the envelope which we were looking at for sales processes. You've got all these leads. Only 100 of those leads are turned into prospects that you might get, and only 10 of those might be customers you actually land. So it's quite a big filtering process. This is what's called the sales pipeline. So production process modules. So what we have here is we have sales and operations planning, and that feeds demand management, and the result of demand management is planned independent requirements. So you might be asked, what are planned independent requirements and what are dependent requirements? So try and find a definition for those. But dependent requirements are basically, for example, if you make a bicycle and it's got 2 wheels and a frame, the bicycle has dependent requirements of the bicycle wheels and the frame. Those are dependent requirements based on they're needed to make the bicycle. Independent requirements are things that come from you might be making for stock. You might be the whole reason, number of reasons why you might want to make bicycles. So have a look at the planned independent requirements against dependent requirements. Long-term planning is another way of feeding in to make a certain number for stock based on long-term projections of how many the company tends to sell over a period of time. So you would be probably doing that on top of what you're doing from what orders are coming in and what's being driven by orders. As a result of planned independent requirements, you then go to materials requirements planning. It will do 2 things. It will work out what planned orders it's got to make, and it will also be looking to see if it needs to buy anything to do that. So we'll probably come on to that in a second. You then have production order creation. There will then be production orders, and there will be a capacity requirements planning to see if finally there is enough capacity on the shop floor that you can confirm, and then if there is, then you have production execution. Everything gets loaded to the shop floor. Goods issue happens, goods receipt happens at the end of it. Okay, so here's the planning table. What is a planning table? Well, it's got, you can see it's got available capacity in it, so units of capacity, and it's got available quantities that are available in terms of material. So it works out capacity that's available to make things, and it also looks at materials that are available to be used or to be sold or to be shipped. So have a look at what the planning table does. It's a key part of ERP. Kanban signal replenishment. One way of working a Kanban system is you just have two bins. You paint the bottom of the bin pink. When the bin's empty, you turn it upside down, and the storeman brings automatically another bin painted pink on the bottom, but the right way up with a whole load of components in it. You can do this in a number of ways. There can be electronic signals. Typically there's a sealed area between the stores and the side of the manufacturing line which other people aren't allowed to go into, and it's the storeman that delivers the those components. And I'm sure all this will be automated eventually. In some places it is. In Germany they've got something called what is it called? Industry 4. And Industry 4 is all about automating everything, so you wouldn't have a single person on the shop floor, and that's getting very close to being possible. And SAP is highly involved with this Industry 4. Here's some organisational structures, and SAP defines levels of organisational structures in this way. So here we have the client. So we link to a client, and you could think of the client as being the holding company, the overall global holding company, and company codes as being country codes. So a company code might be the US plants, US area. In the case of GBI, we also had the Heidelberg area, the German side. So you have D and US as the company codes, and then under that you have various plants like Dallas, Heidelberg plant in Germany, and then under that you have storage locations where you keep and ship things and move things about to. It's a bit more complex than that. So here's an accounting view where you also have controlling areas. So that's a management accounting area. That one's Germany. Chart of accounts for Germany, so that's how their accounts are formed, and you have to set that up before you can do anything with ERP. In our case it's done for us by SAP through the University Alliance, but if you had a system, normally you'd have to set up the chart of accounts, add a chart of depreciation, and you'd have a credit control area as well. And then down below that you have the company code, which is this. The sales organisation, distribution channel, divisions, all of those things are part of the sales part. And then you have different plants, storage locations, shipping points. So that's a kind of more complex view of organisational structures. Okay, so holding company, national areas, plants within those national areas, storage locations within those plants, and then you could have distribution channels in terms of a distribution centre. And it's a bit more complicated, but in the exam we will just be looking at that. Production capacity. So here we've got production capacity and what influences it. Notice here we've got a capacity utilization of 100%. Isn't that great? That's a really good factory, but in actual fact utilization is usually lower, and the factory manager, the production manager's job is to keep this as high as possible. The rate of capacity utilization is normally less than 100%. Capacity is equal to the operating time within the block of machines, the number of individual machines or individual capacities or individual capacity areas within that area that's being used, and then multiply that by the capacity utilization as a percent. And so that's what you need to think about, what will increase or keep your capacity utilization up to make best use of what you've got. You can have things like shift sequences. So shift sequences are, you tell the ERP system how many people it can have to work on things today. So there might be an early shift, there might be a night shift, there might be a late shift, when they start and stop, who's doing what, and So these shift sequences you can bring on and off, and it allows you could have an overtime shift sequence, and that allows you to work out what your capacity is. So capacity requirement is a standard value of capacity times order quantity over a base quantity, and then you have duration, which is pretty much the same thing but divided by the number of splits. So splits are a thing which you can do to do activities in parallel, so perhaps we'll come on to splits, because it's a bit you've got to watch out between shift sequences, which is defining who can work when, and other sequences which allow you to split things. Okay, so routing sequences. So this is the difference I was talking about. Here we've got shift sequences. Now I'm talking about routing sequences, and so remember when we were looking at the routings, you had a sequences button. You can go between these two. Routing sequences allow operations that could be achieved in parallel to be made other than a linear chain of operations. What it does is it allows you to choose a sequence to set up a pre-made sequence that you can implement that cuts your production time. It gives you more options. The result is you'll have a parallel winding route through operations on the shop floor. Production versions. So you might decide to have lots of production versions for different products that you can just enact when you get an order of the right type for those different types of products. So a production version can be selected to run later. You set them up and then you can run them later, depending on which ones you think are most appropriate. You don't just do all the inputting for a particular order on demand as an order comes in. That would be silly. It would be wasting of time. Dependent requirements. So what is a dependent requirement? Okay, so here we've got an order for a bolt and nut assembly, and MRP is going to make to make that, if there's 10 of them, it's going to make 10 bolts and 10 nuts. So we've got planned independent requirements for bolt assemblies, and we've got dependent requirements of bolts and nuts that we have to make those. So sub-assemblies or piece parts are being made because of a forecast that sales orders yet to be taken will require them in the future. If a product is called for and it has a bill of material that includes lower level parts, then MRP will make or buy those parts if current stock levels require it. So materials requirements planning is going to make a choice between, have we got enough, or do we either need to make some of these parts or buy some of these parts, depending on what type of parts they are, and whether we want to outsource some of those. Instead of making them, we might buy them in. Process steps in materials resource planning. Okay, so you've got sales and distribution. It produces a sales order. Demand management then has planned independent requirements, which feed into a net requirements calculation to say, are there any material shortages? It's not allocating production space or thinking about that at the moment. There might be long-term planning feeding in to net requirements as well, providing some fixed planned orders that you've decided on before. Eventually you'll have a whole series of planned orders. They could be a mix of fixed and new orders based on sales. You have a procurement quantity calculation then once you have net requirements calculation being made of what's got to be bought to meet this order. Then you'll go through scheduling to find out have you got enough space, possibility of realistically of making it. Then you define the procurement proposal, and then it could be that there's a secondary requirement, in which case you've got to go back to the planning file to find out if there's any more elements of this order that are going to come through. As a result of the procurement proposal, you will do two things. You'll have production order creation, and you'll do a capacity requirements plan to see if there's enough room on the shop floor or in whatever production process it is. So So you determine the requirement of lower level parts by exploding the relevant bills of materials to get the dependent demand requirement. And that's what you'll need to think about buying what you don't have, or making what you don't have. Planning scope. What is planning scope? Well, this is a simple example where you've got plant XX01 and plant XX02. Most of the air conditioner is made in plant XX01, but the motor of the fan assembly is made in plant XX02. So you need to define a scope of XX01 plus XX02 to enable ERP to know that it needs to get motors from plant XX02. Otherwise it will ignore the motor. It will do everything that it's supposed to in plant XX01 and you'll end up with no motor. So planning scope is the extent of plants that are going to be used to fulfill a particular order. Sounds very simple, and it is really, but you just need to make sure you've covered scope. In financial accounting, you have accounts payable subledger, so AP, and this deals with purchases. If something's purchased, and then it will deal with returns and allowances. So if you purchase something, it was faulty, you send it back. Purchase discounts. It's just reminding me that I've got to send something back to Amazon. And then you've got purchase discounts and payments and other adjustments, and all those things are dealt with in the accounts payable part of the general ledger. So you've got the general ledger you have accounts payable and you have accounts receivable within the general ledger. In accounts receivable, this is where you deal with sales. So the sales that you've made, those balances less the returns that are coming back to you, the allowances that you've made for particular changes of value that might have happened. You might write off some of the debt. Sales discounts, all that kind of thing. That's dealt with in the accounts receivable subledger. And you normally have something called the net number of days that the customer needs to, or is allowed to pay after. Sometimes they'll pay a lot longer than your terms and conditions say. So you might have net 30 days. It can be net 90 days with big customers, and even then they don't pay after 90 days. So those are things to consider in terms of general ledger, accounts receivable, accounts payable, etc. You also have reconciliation accounts, and what that's doing is it allows you to see different accounts and you reconcile differences between them. You think of a shop that runs a float during the day, and at the end of the day you find that you've got a mismatch in terms of what you thought you'd sold and what the value is that you've got. You have a mismatch report which allows reconciliation of different accounts across different companies. And you set up a reconciliation account by just taking a general ledger standard account and defining it as a reconciliation account, and we did this in the lab. Okay, so there's something called first in, first out, last in, first out, and weighted mean. So what does all this mean? Now, I don't know whether no, I didn't. Okay, so what this means is that you have, in terms of first in, first out, when you buy in some components and they go into stock, you take those before you take any other components for use in your production. The alternative is last in, first out, where you take the components that you've bought in, you take from the last ones that have arrived and put those into your production, leaving ones that came in before. Why does that matter? Well, if you use a weighted average, it doesn't really matter, because you're taking a mix, a mean of each of those components, some that came in a long time ago, some that came in last week. If they've changed in price during that long period, then you can kind of bias the accounts, particularly if you're thinking of you're coming into your reporting phase and your investors are going to wanting to see whether you're making a good profit. You can make it look that you are if, for example, the components that were bought a long time ago cost a lot less than what you've also bought and got in stock now. So what you do is you take a first in first out strategy. You use those old components which cost less. The costs to production will be less, and therefore there will be more profit. It will make the accounts look as if you're trading well, whereas actually in a 3 months time you might have to go on to the more expensive components, and immediately production profit is going to drop because the costs are going to rise because you're using more expensive components. So these are ways you need to be aware of people being able to frig the accounts to make their company look good. Okay, so we're getting towards the end now. So cost, profit, center accounting. What are cost centers? Our cost centers are for kind of back office areas where, like accounting, information systems and services, and human resources, that don't actually generate a profit, but they need to be accounted for in terms of how much they cost. Profit centers are areas which are involved with manufacturing, actually delivering orders, and therefore they can be, you can work out how much profit they've made, but you can't do that with the back office because they're not making profit. Strictly speaking, information services can rent out some of their unused capacity and make a profit that way, but forgetting about that. MRP and consumption planning. So you can use MRP to choose how much you run, how much you produce, which is this run here, which we've talked about a bit, by exploding the bill of material and then choosing what to run with, needing to order or make. But the other way of doing it is consumption-based planning. So this is where you buy things in based on when the stock gets down to a certain level. So here we have the amount of stock in stock. It's decreasing all the time as production's using it, and when that stock gets down to this level, which is called the reorder point, this line through here, then it triggers an order. This is the replenishment lead time which it takes to get that order in. So you obviously don't get the products coming straight away. Just-in-time manufacture has reduced replenishment lead time for large companies to much smaller than it used to be, but there still is a replenishment lead time. And then if the stock keeps falling, supposing there was some kind of crisis and this replenishment lead time became much bigger, then eventually that line would get down, this line, which is the stock level, would get down to the safety stock level. And what you're trying to do is have the safety stock, the replenishment made before you get down to safety stock, or ideally right at the point when you did. So safety stock, if you are going below safety stock, then the system will trigger an error, and it will put up error messages on the screen of the ERP system, such as something like this. So here we've got there's an exception message, and this says 15, which is a code, and if we were to look up code 15, that would have a message. Here's another exception message, code 90, and code 90 triggers this 96 stock fallen below safety stock level. So effectively what that's telling you is that our stock levels have continued to drop below there, and so where we should have had a replenishment of stock, we haven't had it. So that's something to watch out for. You need to find out, because your production process could run out of stock and the whole thing could grind to a halt, which is what then your production utilization, your capacity utilization will become very poor. So that's when your production managers and purchasing managers get sacked. So you can go and look at this, what's available in stock, and I thought I'd maybe I did it. No, I didn't. I thought I'd shown But these are menus basically where you can go and look through and see what the exception messages are. And here's one: stock fallen below safety stock. Here's another one: abnormal end of requirements planning, etc. Things that need to be looked at. So here we've got inputs and outputs in ERP. We have planned independent requirements coming from orders. We have customer requirements. We have secondary requirements that might come from long-term planning or from another area. We need to deal with stock, and we have fixed receipts. Out of materials requirements planning, which looks at all those inputs, either will come a planned order or a purchase requisition. A planned order will put an order to make things. A purchase requisition will be an order to buy things. And that's what MRP does. It makes or buys things. So here's the exam question format. Typical question: a large share trading brokerage, and we looked at Charles Schwab, didn't we, has based its competitiveness on being able to provide quotes for trades rapidly. However, over the years, further IT systems have been grafted onto the company network without any attempt at consolidation. We saw at the beginning that that's not good, because it makes the system less reliable. As a result, the trade times, which quotes for share trades and system reliability have fallen, while cost of IT per trade has risen exponentially. What's the situation the company faces called? And so your job is to pick one of those answers out. So you could pick a big sob story, but in this case the right answer would be the alignment trap, which is what we talked about previously. They haven't consolidated and improved their network before they tried to align it with business goals. So this would be a question of choose one from this list. That would so against these options there would be radio buttons. If you see checkboxes, then you know you're going to be asked to make a number of selections. So it could be that the right answer was a big sob story, the alignment trap, and IT bankruptcy. In which case you'll have radio buttons, and you pick 3. It's down to you to analyse what the question means in the exam. Okay, so that's kind of sample format, and I hope I've covered everything. If you look at all those things, then in the exam I think you'll be in a fairly good shape, and I wish you well for it. So that's the end of this revision lecture. I wish you well in the exam. It's exactly 60 minutes long, and 22 of you are going to be doing it on a secure exam browser in a Portland lab. 3 of you are doing it in special needs, 2 separate rooms, on Chromebooks. So we'll be delivering Chromebooks to those rooms, and you will be doing the same kind of thing. It works exactly the same way as the Safe Exam browser. It's just that we're using Chromebooks as devices. So I wish you well, and one of the nice things about this exam is it will mark itself, so we'll know the result pretty quickly, and I will try and post it as quickly as I can. Sometimes we're told we have to hang on while they rubber stamp things, and obviously the external examiner has to look at it. But thank you very much for all your attention during the course, and if you've got questions, then you can email me, and if I can, I'll come back. I've got a lot of marking on at the moment, so dissertations and things. But thanks for your attention, and best of luck, and I hope you have a good summer. Thanks very much.